audible? Hello.
Good morning, sir.
Good morning. So I think it's 8:05. We should start. So okay. So anyway, we'll start. So actually, I'm planning to conduct up to 6 hours of lectures during this period. So I will try to touch up all the relevant topics. Then in between, if you need any special attention or a special emphasis on any topics, you can inform me. So that I will arrange after this. As so, we'll start. First of all, I would like to tell about about waveforms and signals, because it's very important as far as networks goes is considered. So the voltage and currents in electric circuits are described by three classes of time functions. So it's basically mathematics only. So we can have periodic. We can see that there are periodic functions which are recurring. The shape is repeated after certain periodic times. Then we have non-periodic functions. That is, we cannot predict what is the. We cannot write that function as a periodic function. That is called as non-periodic function. Then random functions, they occur randomly. We cannot write any particular function to represent it at any particular time. So it will be totally random. In our course, we will be interested in the first two category, mostly periodic functions for analysis in the frequency domain, and non-periodic functions, especially for the transition state analysis. We will not be touching on the random functions in this course. So to tell an example, the most familiar and the most commonly used periodic function is the sinusoidal function. So before we understand that, let us give a definition, mathematical definition for periodic functions. So if a voltage V of t or a signal V of t is said to be periodic if we can write that voltage or that function V of t as equal to V of t plus some capital T, where t is called the time period of this signal. Okay. So if we can represent any signal like this, then they are called as periodic signals. If it is a function, then it is called a periodic function. Okay. Example, let us say that a voltage V1 is represented by V0 of sine 2 pi t by t. So everyone is familiar with the voltage waveform. That is the shape of this sinusoidal function. So when you represent a function like this, we know that this capital V0 is the amplitude. So this sinusoidal function is now oscillating between plus V0 and minus V0. And what is written is the function that is sine 2 pi t by t. So you know that you can write a sinusoidal function as equal to sine theta. So this theta is nothing but the angular frequency omega into the time period, and this omega could be written as equal to 2 pi into f, where f is called the frequency in hertz. The name of omega is called angular frequency, and the unit is, anybody know? It will be radians per second. Okay. Another unit for hertz is cycles per second. What is mean by cycle is the number of oscillations that will occur in 1 second. Okay. we can represent this f in terms of the time period that we have mentioned here. That is f is equal to the inverse of the time period. That is f is equal to 1 by capital T. T is called the time period. So we can also represent omega is equal to 2 pi by T. Okay. So in short, we can represent the uh, waveform, that is the function v1 of t, as equal to v naught sine, instead of theta we can write as 2 pi by t into t. Okay, that is how we have written this in terms of the time period capital T. I hope it is clear. If any doubt is there, you can ask, or you can put in the message. So Merry Christmas to everyone. I am going to unmute all the participants who have joined till now, so that you can speak.
Good morning, sir.
Good morning, everyone. Okay, so till now, those who have joined, I have allowed you to unmute and speak. If you have any doubt, just interrupt and ask. Those who are joining late, you can put in the chat. Okay, now proceeding. Another kind of periodic waveform is on, which is very common that we are going to use in our course, is called the periodic pulse waveform. It has this following shape. The function could be represented like this: v2 of t. So it will have a value plus v1 up to time period 0 to t1. Okay, for this time period 0 to t1, it will be a constant value of plus v1, and at between t1 to the capital T, that is the time period, it will have a particular value of minus v2. So up to t, it will have a particular value t. Then it will oscillate again. So since it is a periodic way, so the function is defined like this. So it is expected that it will oscillate, or it will have the same shape for the rest of the period. So it will continue like this. Okay, if we extend the time axis like this, so at this time period, which is nothing but t plus t1, it will again cross the time axis, and at period t is equal to twice t, it will complete another full cycle. Okay, I hope it is understood. Coming back to the sinusoidal signal also, we will have at this will oscillate like this. Okay, assume that it will oscillate like that. Okay, so it will cross this axis at again t is equal to 3t by 2, and 2t, it will cross this time axis at same point. Okay, okay. So sinusoidal function, a sinusoidal voltage is given by v of t is equal to v naught of cos omega t plus theta, where theta is called the phase shift. So we can represent a sine function in terms of cosine function also, because we already know that sine theta is nothing but cos of 90 minus theta, right? So what happens is that if we shift the cosine voltage, so what is the shape of this cosine cos theta function? If you remember in your course, you have drawn this cosine function. So if we, this is cos theta function. Okay, so it is nothing but the sign that is shifted towards the left side, right? So it is advanced sine wave. So if I shift this and it crosses the zero axis at pi by 2, and this is 3 pi by 2, and this is pi. Now if I shift this voltage to the right side by 90 degree, so what we'll get is the sine wave. Are you following? I shift this by an angle pi by 2, I will get this. So I'm shifting this voltage, this signal, this function towards the right side. Okay, by an angle 90 degree. So this point will come to the zero crossing. Sorry, it will come to this point, which is pi by 2, and it will cross the zero at zero time instant, and this one will be pi, and this point will be 2 pi. Okay, so this is nothing but our sine theta. So we can represent a sinusoidal voltage by shifted cosine voltage. So by what amount it is shifted is given by this theta degree. In this particular case, I have marked theta is equal to minus of 90 degree. Okay. So let me here I should have written that this is omega t minus 90 degree, right? Or I can put 90 minus. Okay, let me put it as okay minus 90 degree. Okay. So I hope you have studied this in your mathematics, right? This thing, your plus two. So where V naught is called the amplitude, this is called the amplitude of the voltage, and omega is called the angular velocity or angular frequency that we have already seen, and theta is called the phase angle. Okay. Then we have derived the relationship that is F is equal to 1 by T, and it is expressed in hertz or cycles per second. So we can also write that is cos theta is a periodic function. So we can write cos of omega t is equal to cos of omega t plus 2 pi, right? So if we add 180 degree to this cosine, it will be the same value, and t could be written as and omega t and t are related by omega t is equal to 2 pi. So when we compare this with, so we know that cosine function and sinusoidal functions are periodic functions. Okay, so I can express this as equal to omega t plus that time period, capital T. So what happens if I take omega out of this function? What I will get is t plus t by omega, right? So what is this? This is nothing but our theta, right? When we compare this with the general expression cos of omega t plus theta, so this is our theta. So we can write as theta is equal to t by omega, or sorry, theta, or we can write omega give me a second. So coming back here, I can express the time period t is equal to theta times omega, and for periodic function this theta is equal to 2 pi, right? So this is equal to 2 pi into omega. Sorry, I made a mistake here, some understanding problem. So coming back here, we know that the cosine function is a periodic function. So we can write cos of omega t. So let us start from here. Cos of omega t could be written as cos of omega t plus 2 pi, because we know that the cosine function is a periodic. Cosine and sine function is a periodic function with period is equal to 2 pi. Okay. Now what happens when we take out omega here? So we can write this as cos of omega t plus 2 pi is written like cos of omega into t plus 2 pi by omega. We can write like this, right? Now we have defined a periodic function, that is v of t is periodic. If we can express this as v of t is equal to v of t plus some capital T, where T is called the time period of this function, right? Now, when we compare this expression with this expression, we can write this as equal to cos of omega of t plus some capital T, which is called the time period of this cosine function, right? So then we compare what is this T, compare this T with this 2 pi by omega, we can write T is equal to 2 pi by omega, right? So that is how this relationship is written. That is omega t is equal to 2 pi. You cross multiply this, you will get this relationship. I hope that it is clear, right? Any confusion in that? Any doubt till now?
No, sir.
Okay. Some confusion I made here, but don't get confused. So we know that sine and cosines are periodic functions with period t is equal period 2 pi. So we know that the t, but this period has got a dimension of time, so it should be t. So we cannot put here. Whatever I have written, 2 pi is having a unit radians, which is an angle. So omega t is having that angle. So when you take out omega, what remains is the time period. So you take omega common out of this, so we will get this radians divided by omega, radians per second. So you will have the dimension of this as time, dimension of time, or unit is seconds. So we can write this as function. So if you write this is equal to v of t, so on the left hand side we are having this function v of t, which is our cos omega t, which is a function of time t, and on the right hand side we have proved that it is equal to v of t plus t, because we already know that cosine or sinusoidal functions are periodic with period is equal to 2 pi, okay, or time period. If you express it in terms of the time period, it is periodic with time period t is equal to 2 pi by omega. Another concept that is required is the concept of time shift and phase shift. So I have already we have already seen that we can shift this cosine voltage by an angle equal to 90 degree, and it will become the sinusoidal voltage. Similarly, I can shift it anyway, right? So by what amount I have shifted? The question is by what amount I have shifted this cosine voltage. I have shifted this voltage by an angle theta. So that is called phase shifting. Okay. So I have phase shifted this cosine function by an angle theta, so that it has become equal to a sinusoidal voltage. Similarly, I can time shift it also. Here, what I have done is what we have done is time shifting this by an angle by a time period capital T. Okay. So we see that when we time shift this cosine voltage by an amount by an time period capital T, it is equal to the same function cos of omega t itself, right? So the meaning of that is, let me draw a sinusoidal function. So this is, let us say it is sine omega t. So it is going to make a complete cycle at theta is equal to 2 pi. So I am demonstrating what is meant by time shift. So I represent this by time axis. So let me mark this as also as in terms of time t, that is time period. So this is sine omega t, right? So what I do is I will shift this by an angle t plus the total time period, which is capital T. So what will be the shape of this voltage? the shape will be preserved. Only thing, it will be shifted by an angle proportionate to this capital time period t, so that this signal will start from this period. Okay, this region, like this. So this is t. Okay, let us assume that there is no the function is, we are taking only a part of this function that ranges from, okay, we are interested in this region only. Okay, actually the function is a periodic, so it will continue like this. Okay, so if the function v of t is equal to cos omega t is delayed by tau seconds, we get v of t minus tau. So when we delay means we have to subtract the time, okay, t minus tau, so that we will have, so we are delaying cos of omega t by an amount t minus tau, that is uh, I have explained in terms of this sinusoidal. Here I have not delayed, I have advanced. So when I add this, it is called advance in time. When I subtract this time period, it is called delay. Okay, so we can write it is equal to cos of omega t minus theta, because we know that omega t is into omega into t will have the dimension of an angle. So omega tau is equal to theta. So we can express a relationship between this tau and this theta. So can you see this? I will rewrite it here. So we take the function cos of omega t, and when we delay this, Sanjay Kumar Yadav raised your hand. So if you have any doubts, okay, you can talk. Okay. So I have to delay this function. So what I can do, I can delay by subtracting this tau time. Okay, t minus tau. In terms of phase shift, it will be cos of omega t minus theta, right? Now you can compare this. So a time shift of tau is equal to a phase shift of theta, right? So what I have done here is I have phase shifted by an amount 2 pi. Okay, because capital T is the time period. And we know that sine and cosine I have got are periodic functions of period is equal to 2 pi. So that I will get back this same shape that is crossing from T. Okay. So if you are not talking, you can mute your mic. Okay. Now I write this relationship like tau is equal to tau times omega. You cross multiply this inside, and we can write tau omega is equal to theta, or tau, the time shift could be represented in terms of theta as equal to theta by omega. So a time shift of tau seconds to the left of the graph produces v of t minus tau, resulting in a phase angle called an advance. Okay. So when we add the time, it is called advancement in time, like we have seen in the case of the sinusoidal function here. I'm advancing it, right? I'm adding a shifting this by an angle theta, or I am advancing it by a time period is equal to capital T, or conversely, a phase shift of theta corresponds to a time shift of tau. Therefore, for a given phase shift, the higher the frequency, the smaller the required time shift. It means that if the frequency of the signal, so we know that omega is equal to 2 pi f, or this omega is proportional to the frequency. So what happens when we increase the frequency? When we increase omega, it means that the time shift is going to, that is, if you're for a given phase shift, if theta is given as a particular value and our signal is having a higher frequency, that is omega is high, it means that the time shift required is getting reduced, as you can observe from this relationship. Okay. Are you getting my point? What I meant to say is that if you want to shift this signal by an amount equal to theta, what is the amount of time shifting that is happening for this particular signal? That is the question. So the time shift is not fixed. It is going to depend on the frequency of the signal. So if the frequency of the signal is high, then the time shift is less for a given phase shift theta. So that is the meaning of this sentence. Any doubts in that? Sanjay is telling video is not clear. Video clarity problem is there. I hope that it is somewhat visible. So shall I proceed? Did you understand the concept of time shift and phase shift? Are you able to understand? Yes or no? Okay. Now what happens when we combine periodic functions? Okay. So as let us assume that we have two functions. Let us say v1 of t. Let us assume that it is periodic. It means that v1 of t could be written as v1 of t plus some time period t1, capital T1, let us say. So it will repeat. This v1 of t will repeat again after some time t1. And let us say we have another function v2 of t, which is also periodic. So that I can represent this as equal to v2 of t plus t2. Okay, why I wrote this? Because we are considering that v1 and v2 are periodic functions. Okay. Now my question is, what happens when I add up these two voltages? Let us say the new voltage, new function is v of t, which is the sum total of v1 of t and v2 of t. Question is it periodic? How can we find out? So by definition, we can see that v of t is periodic. So v of t is periodic if we can represent this voltage v of t is equal to v of t plus small t plus some capital T, which is the period of the new function, that is v of t, right? That is how we have defined this thing, right? So this will happen. So this will happen when we can express this T1 and T2 like if you multiply some function, some integer n1 to T1, and we multiply another number n2 to the period of the second voltage. That T1 is the period of the first function, and T2 is the period of the second function. You multiply with the period of the first function with an integer n1, and multiply the period of the second function with an integer n2, and we can write this as n1 T1 is equal to n2 T2, which is equal to T. So it means that the ratio of the time period of the two functions T1 by 2 could be written as the ratio of two integers, that is n2 by n1. Okay, so since n2 and n1 are integers, so these should be integers. So the ratio n2 by n1 is a rational number. It will be a rational number. Okay, then only we can say that the sum total of these functions v1 and v2 is periodic. So the sum of two periodic functions with respect to periods t1 and t2 is periodic function if a common period t could be written as equal to n1 t1, that should be equal to n2 t2, where n1 and n2 are integers can be found out. Or in other words, we can say that the ratio of t1 by t2 will be ratio of two integers. So ratio of two integers means it is a rational number, that n2 by n1 will be a rational number. Okay. Otherwise, the sum is not a periodic function. So what is the rational number? So we have said that n1 and n2 are integers. Then only we will get the ratio of n1 by n2 or n2 by n1 as a rational number. So what is rational number and what is irrational number? Can you give me an example for irrational number? If you can give me an example for rational number, then you will understand what is rational number. So what is the definition of rational number? It is a ratio of integers. Okay. So here itself I have given you the definition of rational number. So if we can represent any number as the ratio of two integers, that it is called a rational number. So if you cannot represent that by the ratio of two integers, then it is called an irrational number. The most common example is our pi. Okay, there is we cannot represent pi by a ratio of two numbers. The most common approximation is like 22 by 7, very easy to remember. But again, we know that it is not the correct approximation. So we can never represent pi in terms of the ratio of two integers like this. Okay, I hope you know what are integers. Okay. And the second most example that we use in our uh, BTech is the Euler's number, that is E. So I hope that you know what is the value of E. You can find it in your scientific calculator. We cannot express the values of Euler function in terms of ratio of two integers. There are very interesting websites also which gives a lot of interesting concepts on this E and pi. Then another example I can give you is root 2. So we can see that. So if you take this square root of 2, you can see that it will be some 0.707 like that, it will be a repeated value. We cannot find a pattern for this. Similar is the case with pi also. It is 1.414 like that it will. So this is an approximated value. Similarly, this is an approximated value. But you can see that the digits are there are innumerable number of digits which are not repeating. We can never see a pattern for these kind of values. Okay. But is root 9 a irrational number? It is not an irrational number. Okay, because we know that it is root 9 is equal to 3, which is an integer. So this is not an example for irrational number. It's a rational number. Okay. Another question is whether 1.5 is an irrational number. Is 1.5 an irrational number? Yeah, because we can write that this is equal to 15 divided by 10. This is nothing but 3 by 2. Because we can express this in terms of the ratio of two integers. So it is a rational number. Okay. So that is the definition. That is how we can find out whether two functions, the sum of two functions or sum of any number of functions is periodic or not. So you will better understand in terms of this example. So in this question, we have to find what is the period of v of t, which is the sum total of two periodic functions. We know that cos and sine are periodic with period 2 pi. So find whether they are periodic first. If they are periodic, then find its period. So how do we start? So let us take the first function as cos phi t. So that is our v1 of t. So if we take cos of phi t, we can write it as periodic, right? So it could be written as cos of phi t plus 2 pi, because we know that the cosine is periodic with a period with a phase with angle 2 pi. So I can write like this, right? If I add 2 pi to this angle phi t, then it will give back the same value, right? So what happens if I take out this phi out of this? You'll get t plus 2 pi by 5. Now it has come to the form of, so this is having the form v of t, let us say, and this has come to the form of v of t plus capital T, right? Where capital T is equal to 2 pi by 5. So for the first function, you can write the time period of this function is equal to 2 pi by 5. Because we can compare this. This is our capital T here. Okay. What about the second function? So I will call this as V1 and this is V2. Okay. And the second function, V2 of t is 3 sine 3t plus 45 degree, right? We know that sinusoidal function is periodic with period 2 pi. So again, I can add 2 pi to this. So this could be written as 3 sine 3t plus 2 pi plus the phase shift. We don't have to touch the phase shift. It's assume that this function is phase shifted by an angle 45 degree. It doesn't matter here. So leave it as such. We just take out this 3 out of this time period. So we can write this as t plus 2 pi by 3, right? Plus this 45 degree. Now when we compare this with v of v2 of t plus capital T2, this is time period of this 3 sine 3t plus 45, we can write T2 is equal to 2 pi by 3, right? Now what is the next step? You should check the ratio of T1 to T2. What is T1 by T2? T1 is 2 pi by 5 and T2 is 2 pi by 3. So we can see that it is the ratio of integers 3 and 5. So T1 by T2 is equal to 3 by 5. So this is a rational number, right? So this is rational. Am I right? Because it's a ratio of two integers. Hence, V of t is periodic. Now, what is the period of V of t? V of t is periodic means we can write V of t is equal to V of small t plus its time period capital T, right? Do you follow? And what is this capital T? So in the previous slide, I had told you we can, if a function is periodic, if a function is periodic, when we add two other functions. So when we add v1 of t and v2 of t, which are periodic signals, and we get a new function v of t, then we can say that it is periodic if we can express v of t is equal to v of t plus capital T. So that will happen if t1 by t2 is a rational number. Then we can write the period of the new function capital T is equal to n1 t1 plus n2 into t2, right? So here t is equal to, when we cross multiply this, we know that t1 by t2 is equal to 3 by 5. What happens when we cross multiply this? It will be 3t 5 t1 is equal to 3t2. This is our capital T, right? On cross multiplying this ratio, we have already found out what is t1 by t2, which is 3 by 5. I cross multiply this, I can write as 5t1 is equal to 3t2, which is our time period of the new signal, which is the sum total of the two functions. Okay. I hope you understand. You can take any one of these and find out the ratio. So the time period of the new voltage V of t is 5 times of t1. So that is 5 into what is t1? The time period of the first signal. So what is the time period of the first signal? It is 2 pi by 5, right? So that is equal to 2 pi. So this is the period of the voltage V of t, right? When you add up these two signals, two functions. Are you following?
Yes, sir.
Is t common period? Akhilesh Trivedi is asking, is t common period? Yes, capital T is the common period. So Akhilesh Trivedi, are you facing any problem in unmuting? You can ask directly, because otherwise I
Sir,
will get confused.
it's Ashleisha Dwivedi. Actually, I'm having noises in my house. That's why I uh, typed the question.
Because when I share the screen, I will not be notified whether any message is coming or not. That is the issue. So when you put message, no, it will be like hidden. I will not know that a message is written. I have to check the message. So what happens is that I may cross some points. Then I will wonder where you have asked the doubt. So I hope that your doubt is here. I hope that it is here. So this
Yes, sir.
capital T is
Now
the
that I'm
common time
clear.
period. Yeah.
Yeah.
It's a common period. It's a common period when we add, because we have written. So I will write one more sentence here. So V of t is equal to V of V1 of t plus V2 of t. Okay. So V of t is periodic. If you can write V of t is equal to V of t plus capital T, where t is the time period of the new function, which is the sum total of the functions v1 and v2. Okay. So I am trying to write the small v. That is why it is looking like this. Actually, it is small v. I am trying to write looking like r. Okay. Sum total of these two signals. I hope that concept is clear. It will be more clear if you look at one more example. So consider this v of t, which is the sum of two functions, cos t and cos 2 pi t. So the question is it periodic? And discuss it. So let me call this as v1 of t and this as equal to v2 of t. Now take out each function one by one. Let us take out cos t. Okay, let us consider cos t. So we know that sine and cosine are periodic with period 2 pi. So cos t is periodic, which means that I can add 2 pi and get the same value, right? What is the value of omega here? Omega is equal to 1. Okay, so that actually this is some value. You just take it is value. Don't take it this as having a dimension of time. Okay, this is having a dimension of radian, that is angle. Okay, it is radians actually. So I can simply add up 2 pi, and since cosine is a periodic function, I can add 2 pi and write cos t is equal to cos of t plus 2 pi. Okay, so don't get confused here. Let us assume that omega is equal to 1 here. Okay, that is why. So even if we take out 1 out of here, it will have the dimension of time. So we can write the time period of this first function as t1 is equal to 2 pi. We cannot take out. So we can directly compare this with. So this is our v1 of t, and this is our v1 of t plus capital T1. So when we compare this, we can write as the time period of the first signal is equal to t1 is equal to 2 pi. Similarly, we can take out the second function v2 of t is equal to cos 2 pi t. Again, we can add it up because cosine is periodic function. Cos 2 pi t will be equal to cos of 2 pi t plus 2 pi. And adding 2 pi to the angle, so it will have the same value. Now I have to express this as like this: some t plus some capital T, some small t plus one other capital T. So what should I do? I should take out this 2 pi from here. So I can write this as t plus some 2 pi by 2 pi, which is nothing but equal to 1 here, right? So this could be compared with p2 of t plus some capital T2, which is the time period of this second function. So what is T2 here? T2 is equal to 2 pi by 2 pi, which is equal to 1 here. Now take the ratio T1 by T2. What will it will be? 2 pi by 1. Now the question is it rational? Is this rational? Yes or no? Is this rational?
Irrational.
Irrational, because pi is coming here,
Because
right?
of pi.
Yeah. 2 pi is not an integer, so it is not rational. So what is your conclusion? The conclusion is v of t is equal to v1 of t plus v2 of t. We are adding two periodic signals, but in this case, we can see that when you add these two periodic signals, v of t is not periodic. Okay. Okay. So if you are having two periodic functions, when we add up, it need not be that the sum total of these two functions need to be periodic. It can be non-periodic also, depending on the ratio of the time periods of the functions that we are going to add up here. So this is an example in which we are having two functions. You can have any sum of any number of functions here. So for example, if there is another plus sine t, etc., you have to just see whether you can express the ratio of t1, t2, t3, etc., as some ratio of integers n1, n2, etc. Okay. If you can express it, then you find out what is the minimum, what is the most smallest integer by cancelling out the numerator and denominator and find out the smallest integers, then cross multiply it, then you can find out the time period of this signal, which is represented as the sum total of all these signals. See this example. Find the period of v of t is equal to cos t plus cos 2pt. So it is similar to the previous example that we have seen here. Only thing, this 2 pi is replaced with p here in this second example. So p is having a value 3.14 is given. So take this value only. Okay. Don't think that it is the value of pi and put pi here and pi is rational. Don't go to such conclusions. Just take out this value only and find out whether it's periodic. If it is periodic, find out the period. So what is the period of cos t? We have already written it as equal to 2 pi in our previous example. Okay. Now what is the period of cos 2pt? So we can write cos 2pt is equal to cos of 2pt plus 2 pi, right? Because cosine is periodic with period equal to 2 pi radians. Now taking out 2p out of this, so it will be t plus 2 pi by 2p. So we can compare this with say v2 of t plus capital T2. So I can write T2 is equal to 2 pi by 2p, which is nothing but pi by p. Now take the ratio T1 by T2. So that will be 2 pi by p is equal to 2p. And p is given as 3.14. Okay. Which is equal to 6.28. Is it rational or irrational? As you can see, the decimal places are not recurring. It is not recurring like this. It is having two fixed decimal places. It is considered as rational number. Okay. There is no dash given here. That is, it is recurring. Okay, so it is a rational number. Even if it is recurring, also, it could be what do you call? It is a rational number because, for example, 0.3333. This is a rational number because we can write this as equal to 1 by 3, ratio of two integers. So this is considered as a rational number. Okay. So this is a rational number because we can write as equal to 628 divided by 100. Then you reduce this to the smallest integer. So if you use your scientific calculator, you can find out the smallest integer. This could be written as 157 by 25. So this is rational number because we can express 6.28 in terms of two integers. Okay. Therefore, therefore, P of t is periodic. And what is a period? Period t is equal to, you can cross multiply this. So t1 by t2 is equal to 157 divided by 25. So what is t? T is equal to n1 t1, which is equal to n2 t2. You can cross multiply this. You cross multiply this, and you can write t is equal to 25 t1, which is equal to 157 t2. Take out any one. So 25 into what is t1? T1 is equal to 2 pi, right? So that will be equal to 50 pi. Any doubts so far?
Sir, can we put the value T2 is equal to pi by P?
T2 is equal to pi by 3.
Pi by P, sir. So
Yeah.
157 T2 is
Yeah.
equal.
Yeah, you
That
can put. So you want to find out. So or t is equal to 157 t2. Okay. So 157 into what is t2?
pi by P.
Pi by p. Okay.
Yes,
So
sir.
it's pi by p. So what is p?
P is 3.14.
Yeah, 3.14. That we have already expressed as this value, right? 157 divided by 25. Right? So that is equal to 157 into. So this is our 2p, right? Isn't
Yes,
it?
sir.
So there will be some error, like approximation error, right? We are asking about that. So it will be twice into 157 divided by 25, right? Sorry, this divided by 2. Right? So it will be, take it out to the numerator. So it will be 50 times 5. Are you getting this?
No, sir.
So here we have written 2p is equal to 157 divided by 25. So what is p? P is 2 into sorry, t is equal to 157 divided by 2 into 25, right?
Yes, sir.
You just see here. I will use a different coloring if you want. Just hold on. Okay. Just see this one, and this one. Okay. Sorry, not this one. So that's how I wrote 2p is equal to 157 divided by 25. I cross multiply this p is equal to 157 by 2 into 25. Okay. Now we have written t is equal to 157 into t2. Okay. So what is our t2? 157 into pi by p. That is we have written here. What is t2? Here. T2 is equal to pi by p. So that is pi by p. So you substitute this value here. The 157 into pi divided by 157 divided by 2 into 25. Okay. So these will get cancelled. Taking this to the numerator, so that will be 2 into 25 pi, right? So this is equal to 50 pi.
Yes, sir.
Are you getting it?
Yes, sir.
Okay. So whatever you substitute, because for convenience, I just substituted 5t1 here. Sorry, 25t1 here. You can take this value also. Substitute t2 here. You'll get the same answer. Okay. It's up to you. You can take any value. Any doubt? Any more doubt?
No, sir.
Okay. So I hope the concept of periodic functions, and when we add two periodic functions, how whether the new function is periodic or not, we can check it. I hope that concept is clear to you. Now,
Yes, thank you, sir.
okay, let us move on. Another concept that we need in our network analysis course is the concept of average value and effective value. Uh, so another name for effective value is called the RMS value. Okay. So what is it? So let me read this sentence. A periodic function f of t with a period, that is time period capital T, has an average value f average, which is given by 1 by the time period integral over the time period, integral 0 to the time period f of t dt. Okay. So we have a function. Let me say that this is a periodic function. So if you want to take, you can take a sine wave, or you can take a periodic pulse wave. So this is periodic with time period capital T. Then the average value of this is, we have to integrate this from 0 to the time period f of t dt. Okay. So that is the average value. So that is represented within the angle bracket f of t. Okay. So that is the average value. Okay. So if our signal is not starting at the 0, but starting at some other point, let us say it is starting at another point. So this is the time axis. It is starting at some another point, which let us say it is starting at t naught, and it is having a period capital T. So this will be, let us say, t naught plus capital T. So that the total time period is capital T. Then also we can find out the average of this function. So this is my f of t. This is also my f of t. This is nothing but time shifted. Okay. So I can find out, I can write the average, or I can find out the average value as equal to 1 by t integral. So our starting point is this new initial point, that is t naught to t naught plus capital T f of t dt. Okay. So that is how we can find out the average value of a periodic function. Okay, average value of a periodic function f of t. Okay. So you will better understand the application of this when we do some numerical problem. Similarly, we can define another value called the effective value or the RMS value, which is represented by f effect EFF, suffix EFF or FRMS, which is equal to, in order to remember, I will give you one trick. So remember the term RMS, which stands for root mean square. Okay. So it means that it is we are finding out the root of the mean of the square of the function. Okay. So remember the sequence RMS. So F effective is otherwise called as the FRMS. So it's the RMS value of the function f of t, which is the root of the mean of the square. So mean means I have to divide it by the time period capital T. Okay, just like we did for the average value. So mean means divided by the time period, mean of the square. Now we have to find out the square of this function. Okay, so that is f square t dt. So what should the time limits of the integral? Limits of the integral could be t0 to t0 plus t. Okay, that is t0 to t0 plus the time period capital T. Okay, assuming that the function is not starting from 0, it is starting at some point t naught. Okay. Is it clear? Okay. Now coming to this point, it is seen that, okay, I will explain this. If t square is equal to s square t, and average and effective values of periodic functions are normally computed over one period. Okay, because it's a repeating, you don't have to take more cycles. Even if you take 2 cycles, then again you evaluate and find out what is the average value or what is the RMS value, it will yield to the same value. Only thing you have to do some additional computation. So because the cycles are repeating, okay, so it is sufficient to find out the average and RMS value of only one cycle. So that will be the same throughout because they are repeated patterns. It will not going. It is not going to change here. So that is the meaning of this. The effective and average values of periodic functions are normally computed over one period. We need to find out values only over one period. Okay. Now, I hope you are able to appreciate this relationship. If t square is equal to f square of t. So I want you to notice the difference between this thing, that is f square of t and f average square. So what is f average square? That is f of t the whole square, right? So these are different. Okay. So what is average of f square of t? So this is nothing but 1 by t integral t naught to t naught plus t f square of t dt. Okay. So don't get confused that RMS that is effective value square. Our RMS value square is equal to square of the average value. Don't come to that conclusion. We are actually squaring the function and doing this, right? So this is nothing but our FRMS square, right? FRMS or if F effective square. So that is a relationship you can establish. You can see here. by comparing these two results. Only here there is one square root. So we take the square, then it will be that radical will disappear. Okay. So that is f effective square. Okay, I hope it's clear now. So if RMS square, you can see that equal to okay. So what is FRMS square? It is the square of this thing, right? So that when you remove the radical, it will be, you can see that it is equal to this thing itself. So that is the meaning of this, what you have written here. Are you able to hear me properly? Because are you able to hear? Are you able to see the screen? Are you able to hear me?
Yes, sir.
Okay, I think there was some network problem. I hope it is rectified now. Okay. So hope you understand what I meant to say by this relationship. So as you can see here, if I square this RMS value, that radical will disappear. So you understand what I meant to say. There is some time lag. It is. Okay, now let's move on. So find the average and effective values of the cosine wave. V of t is equal to Vm cos omega t plus theta. So what is the average value? Average of V of t is 1 by the time period integral 0 to t V of t dt. So you can substitute for V of t as equal to Vm cos omega t plus theta of dt, theta into dt. So take out Vm from here. So integral of cos omega t plus theta, I hope you know. So what is it? Sine of omega t by omega, and the limit is from 0 to t. So what will happen here? So what is this value? What is the time period? Actually, t is equal to 2 pi, right? So we can write as this equal to, I am replacing t with 2 pi. So 2 pi into omega. So sine So I left out the theta over here and apply the limit 0 to t. Okay. So sine omega into 2 pi. So this is 2 pi omega plus theta minus sine theta, right? So when I substitute small t is equal to uh, capital T, which is nothing but 2 pi, I'll get like this, right? So what is this? So what is this thing? If I take out omega, so that will be theta plus 2 pi, right? Theta plus 2 pi, which is nothing but our sine theta itself, right? Sorry. Let me write this in terms of t itself. Don't get confused here. So this will be sine of, I'm just taking that omega t here. So sine of omega capital T plus theta minus sine of theta. Up to here, is it clear?
Sir.
Okay. Now you can put t is equal to cannot put t is equal to 2 pi. Sorry, we can only put omega t is equal to 2 pi, because we have already seen the relationship between time period t as well as theta. We have written as t is equal to capital T is equal to theta by omega, if you remember. And here theta is equal to 2 pi. Okay. For refreshing your memory, I will tell you from where I took this when we were discussing on the periodic function sine. Here is where I took here that. Okay. So if tau is the time period, tau is equal to t here, then we can write tau is equal to theta by omega. So when theta becomes the uh, period, then tau becomes t. So that is where I took this thing. So t is equal to 2 pi by omega. Okay. So I substitute it here. So what will happen to this? So on the right, Vm by omega t sine omega into 2 pi by omega plus theta minus sine theta. Okay. So what is this? This thing? It is sine 2 pi plus theta. So what is sine 2 pi plus theta? Sine is periodic with period is equal to 2 pi by omega, right? So this is nothing but sine theta. So what happens? It is sine theta minus sine theta, so that the whole term becomes equal to 0, right? So we have the average value of this function, that is Vm cos omega t plus theta is equal to 0. So this is the conclusion. So when we find out the average value of a sinusoidal function means a sine function or a cosine function, it will result in 0 average value. That is, if you are finding the average value over the entire time period, okay. Because if you see the graphically also, you will be able to understand this. If I take a sinusoidal function like this, you know that integral is nothing but the continuous summation, right? You sum up the positive area as well as the negative area. So when you add it up, it will result in a total net area of equal to 0. So that is happening here. So when you integrate it over the entire time period, this is going to happen. Okay. But when you take integrate as parts of the total time period, it will result in a positive or negative value depending on which region of you're taking, which region of function you are taking. For example, in the case of a half-wave rectified voltage, okay, in the case of a half-wave rectified voltage, where you will have only positive pulses, the negative pulses are clipped out. Okay, so this is a particular uh, graph of a half-wave rectified voltage, in which you have only parts of the sinusoidal voltage. So we will have some average value. But when you have full sinusoidal wave, then the average value will be equal to 0. So that you have to remember. Now coming to the RMS value or the effective value. So what is the effective value? The equation for effective value is F effective, which is nothing but our FRMS. Let us find out the square and then take the square root later. So we will you can remove the radical unnecessarily. We don't have to write it everywhere. So it is equal to 1 by t integral 0 to the time period t. So this is general expression. For us it is v of t, and this should be equal to v of t square dt, right? because our function is v of t, which is equal to Vm cos omega t plus theta. Okay. So this is equal to 1 by t integral 0 to t Vm cos omega t plus theta dt. Okay. Now you can integrate this. So integral of this is cosine is sine. I forgot to put squares here, so it should be Vm square into cos square omega t plus t. So take out Vm square. So it is integral 0 to t. Substitute this with that relationship, trigonometric relationship. So cos square theta is equal to 1 plus cos 2 theta divided by 2. So this will be 1 plus cos 2 omega t plus theta, the whole divided by 2 dt. Okay, now you can integrate very easily. Once you write this expression, then you can integrate it. Hope you are getting or following. So this is equal to n square divided by t. So integral of t is equal to, I will take 2 also outside. So integral here when we multiply this dt, so we have integral of dt which is t, and integral of cos of 2 omega t plus theta is sine of this 2 omega t plus theta divided by, when you multiply, open this bracket, it is 2 omega t. Okay, so you have to divide this by 2 omega and apply the limits from 0 to the time period capital T. Okay, so that will be Vn square divided by 2t. So for t it is t capital T minus 0. So that will be capital T itself. And for the second part, so that will be sine of 2 omega into capital T plus theta. So that is the upper limit I have substituted, and substituting the lower limit. So it will be 2 of 0 plus theta, which is nothing but theta divided by 2 omega, right? Now what happens to this function? So what is this function? So I will, so what is capital T? Capital T is equal to 2 pi because it's a sinusoidal function. And what is, sorry, 2 pi by omega, because theta is equal to 2 pi. Okay. Theta in the earlier case, let me put it as theta dash. So I can write this is equal to sine of 2 into 2 pi plus theta. Is nothing but sine of 4 pi okay, 4 pi plus twice theta, right? So you know that sine is periodic with for example, sine of theta is equal to sine of n into 2 pi, sorry, theta plus n into 2 pi, right? So how many times you add this 2 pi, it will again yield the same value. That is meaning of periodic function. However you shift, however distance you travel along this axis, it is going to be periodic. That is the meaning of this n, where n is an integer. So what is this right hand side? That is become Vm square divided by 2t into t plus, when you add the sine 2 theta minus sine 2 theta divided by 2 omega, right? So for the first quantity is sine 2 theta, and the second quantity also, when you open this, it is sine of theta plus, 0 plus theta, 0 plus theta, which is equal to sine 2 theta. So this term will be equal to 0. Okay. So this is equal to 0. Then you open the bracket, so you'll cancel out this capital T. So what is remaining is, it is equal to Vm square divided by 2. And this is our V RMS square. Okay. So what is VRMS? Is Vm by root 2, taking the square root. So what is your conclusion? Conclusion is the average value of a sinusoidal function is equal to 0, as well as the second conclusion is the effective value or the RMS value of a sinusoidal function is the peak value Vm divided by root 2. So you have to remember this result, which will be required for solving numerical problems. Okay. I hope it is clear what I was trying to do here. Any doubts in that previous section? Any doubts here?
Yes, sir, I have a doubt.
Yeah.
So please, can you repeat it again?
Which point you are having doubt?
Sir, in above, where the value is 0, this expression I cannot understand.
RMS value or average value? Which one? First part or second part?
First part, sir.
First part. Here, in the average
Yes, sir.
value.
Yes, sir.
How this value of t is substituted here? Here.
Yes, sir.
Here is your doubt. Okay. So I hope up to here you are following, because here I have integrated this cosine function and then I have applied the limits. Okay. So the upper limit, we know that you have to put the substitute the upper limit, then minus the lower limit. So the upper limit is capital T. So in place of small t, I have replaced it with capital T, and the lower limit is 0. So here we have sine of 0 plus theta, which is equal to sine theta itself. Okay. Now what I have done here is, I have to find out the value of this omega t plus t. Here, when we wrote here, we have written it as capital T. So what is T? T is called the time period. Okay. So T is called the time period. So for a sinusoidal function, the time period is, that is, the function sine theta is equal to sine of theta plus 2 pi, right? So if I add 2 pi angles to this, 2 pi angle to this, then we will get the same function. Or in terms of time domain, so this is in the angle, in terms of the angle, so I can express it in terms of the time also. So theta is nothing but omega t, right? So when I substitute this with omega t, then it becomes the period capital T. So this we have seen already, right? So
Yes.
that is how we have written. When I take out omega from here, it will be t plus t by omega, like that we have written here. Okay. Okay, so this is going to correspond to our theta. So that is how I have written this. The t is equal to theta by omega, where theta is equal to 2 pi because it is periodic with period 2 pi. Sorry, here I should be. Should be 2 pi into t. Should be 2 pi. Now I take out omega out of here. It should be 2 pi by omega. Then by comparing this only, I have written that t is equal to. So this is going to correspond to our capital T, because see the dimension of this omega. Dimension of omega is radians per second. The dimension of this is radians. Okay. So it will have the dimension of time. So this is equal to sine of omega into t plus capital T. Then when I compare this capital T with this 2 pi by omega, I have written as t is equal to 2 pi by omega. Right?
Yes, sir.
This is what we are trying to substitute here. So instead of uh, capital T, so at this step we have got capital T. So in the next step, I substituted this capital T with 2 pi by omega, because this capital T is the general expression. This is a time period. But in our example, we are taking the sinusoidal function. We know that it's having a period of, in terms of time domain, the period is 2 pi by omega. In terms of angle, the angle is 2 pi. Okay. So substituting here, you can cancel out omega here, right? As you can see, omega will be cancelled out. So what remains is we will get sine of 2 pi plus theta here. Okay. So what is sine of theta plus 2 pi? It is nothing but sine theta itself. Because sine is periodic with period. When you add 2 pi to sine theta, it will be sine theta itself. Because you know what is the sine theta is going to look up. Okay. So this is 2 pi. Now what we are trying to do is we are trying to do a phase shift of 2 pi degree. Oh, no. I'm trying to do a phase shift of 2 pi. If I do a phase shift of 2 pi, what will happen to this? The function is not going to change. It is only phase shifted. It is going to remain like this, but it is phase shifted by an angle 2 pi. So that is sine theta, and this is sine of theta plus 2 pi. This is called phase advancing. We have described in a previous slide. This is called phase advancing. I add an angle 2 pi to this original function. Then what happens to this is it is shifted towards the right by a magnitude of 2 pi, which is the same function, right? So what happens on the right hand side? It becomes sine theta minus sine theta, which is equal to 0.
Okay, sir.
To remind you of the concept of phase shift and time shift, let me rewind a few slides. So this is for periodic, where I have mentioned about time shift and phase shift. This is where we have done. So when we have a function, say v of t, so let us assume that we are having a function v of t. I can shift this voltage towards the right or left. What I have to do is only I have to add or subtract a value tau, a time quantity tau. So that is called time shifting. Okay. So I can have time advance. I can advance this function or I can delay this function. Okay. For advancing, what should I do? So advance, let me write it as time advance because I am doing it in the time domain. I can do it in the angle also. So time advance means V of t plus tau. Okay. I have to create a time delay. What should I do? I have to subtract tau. So when I do this, what is going to happen? So let me say that this is my V of t, which you already know that, which is sinusoidal voltage. So this is V of t. Now I can represent V of, so this is the time axis. I can do V of t plus tau, right? So I am shifting it towards the right hand side. Okay. So here it is written. So when you do V of t plus tau, it will result in a leading phase angle, or it is called an advancing. Okay. Sorry, I should be doing V of t minus tau. Okay. T minus tau. It should be t plus tau. Okay. So this should be t minus tau. So this is what I am trying to do here. I can delay this function. So this is delay. I can advance this function. If I do, and what is this advance? This is advanced by an amount equal to this tau, and I can delay. Advance this function by an amount equal to tau. If I do v of t plus tau, right? So it will be advancing by an amount equal to 2. The same thing you can visualize in terms of angle also. So that is what we have tried to explain here. When I shift by an angle theta, the time advance is tau, then you can convert it by the relationship by tau is equal to theta by omega. So that is what we have done here. So in place of the capital T, we have substituted it with the phase angle that is equal to 2 pi here. Okay. So T is replaced by 2 pi by omega, and then we have simplified and found out that the average value of a sinusoidal function is equal to 0, whereas the effective value of a sinusoidal function is equal to Vm by root 2. So any more doubts up to here?
No.
Okay. So we'll proceed with another example. So this is an example for a half wave rectified sine wave. I hope you have undergone a course on rectification, full wave rectification and half wave rectification. So we can represent a half wave rectified voltage as a periodic function like this. where v of t is equal to Vm sine omega t when sine omega t is greater than 0, which is equal to 0 when sine omega t is less than 0. So find out what is the average value and the RMS or effective value. So what is V average? First, let us write the original equation. It is 1 by t integral over 0 to before I let us understand what is done here. Okay. So what is half wave rectification? You have a voltage. So I will take out 2 cycles for better understanding. So this is the time domain, and this is the voltage. So this is the input voltage that we call as Vi of t. And when we do half wave rectification, so rectification means we are trying to convert it to DC voltage. So DC means we will have current only in one direction. So this is an alternative signal or alternative voltage. So when we rectify this, so there are 2 types of rectification we can do. Okay, one is called half wave rectification. The other one is called full wave rectification. In half wave rectification, what we are doing is we will only clip the negative part of the signal. Okay, so we will lose out that part. Okay, so let me use the same variable here, v of small v of t. Why I'm using small is because it is not a constant value. It is going to vary with respect to time. If it was a DC value, I would have written capital T. For example, for these values, I am writing capital because it is going to be a constant value. Okay. So this is called half wave rectification. Only the positive cycles you will get as such. Okay, this region you will get as such. The negative portion will be clipped out. It won't come in the output signal. And for this next cycle, also the positive signal will come here. And it will continue like this. So what is the time period of this signal? It is capital T. So this is capital T. So at t, you will have the repetition of the signal. Similarly, at 2t, you will again have the repetition of that, like that. It will go repeating like that. Okay. So what is this point? This point is exactly in the midway of these two. So this is equal to t by 2. So what do you understand? You should be able to now appreciate that there is signal only from 0 to t by 2. Okay. But in order to find out the average value, we have said we have to consider the entire period. You have to consider the signal for the entire period. That is why I have to take it as equal to 1 by the total time period. But what about our signal? So let me write the expression, original expression. So it will be integral 0 to t v of t dt. So this is the expression to find out the average value. But in our case, when we split this integral, we can see that the voltage is there only from 0 to t by 2, right? Because from t by 2 to t, the value is 0. So we don't have to take that integral. Because integral of 0 is, again, it will yield 0 results. So we have only signal from 0 to t by 2. During that portion, the voltage is Vm sine omega t dt. So this is the average value. Now you can integrate it and find out. So taking Vm common out, and integral of sine omega t is minus cos omega t divided by omega. Apply the limits from 0 to t by 2. So this will be Vm by omega t. Either you can absorb this minus and subtract the lower limit minus upper limit. That is what I am going to do here. So lower limit is cos of 0, which is 1, minus cos of omega into capital T. Okay, after applying the limits of the integral. Now again you can substitute what is t. So this t is equal to 2 pi by omega, right? So actually it's t by 2. Okay. So the t by 2 will be pi by omega. So we will have Vm by omega into 2 pi by omega into 1 minus cos of pi. It will be cos of pi inside here. Cancel out omega here. What is cos of pi?
-1, sir.
It is minus 1. Substitute this minus 1 here. So it will be 1 plus plus 1. So it will be 2. And you can cancel out this 2 from the denominator. So you will get the average value, V average, or the average value of V of t is equal to Vm divided by. So this is for a half wave rectified voltage. The average value will be equal to Vm by pi. So for the full wave, I am leaving it as an exercise for you. You can find out the value for full wave. So full wave rectified voltage will have V of t like this. Okay. So that's I am giving as an exercise for you. Find out what is the average value of this full wave rectified voltage V of t. The clue I am going to give here is this is capital T and this is capital T by 2. So think how the waves are getting repeated here and take the limits of the integral and this base also suitably, and you will get the average value of this. Can anybody guess what is the average value? Any guesswork can you do? What could be the value? Anybody? I will give one hint. The average value of half is this much, Vm by pi. So what should be the value of full? Average value of full?
2 pi.
It should be 2 Vm by pi. So you do this exercise, then you will get the value as 2 Vm by pi. Okay. Uh, Now coming to the second part of this, what will be the effective value or the RMS value? Okay, so V effective is otherwise called the root of the mean of the square. For simplicity, for mathematical purpose, it is better that you first to find out the square of this. Then don't forget to take the square root. So the equation is 1 by t integral 0 to t v square of t dt. So that will be 1 by t. Our v of t is Vm sine omega t, not cos. Sine omega t. Take the square of this. Don't forget to take the square. Now integrate this. Also remember we are considering the half wave, so we don't have limits from 0 to t. We need to take only the limit up to 0 to t by 2. Okay. So this is 1 by t integral 0 to t by 2. Only we will have this value. Okay. So here t by 2, because from t by 2 to t, it is the value of this function is equal to 0. Okay. So taking out Vm square outside here. So we will have integral of sine square omega t dt. So this could be written as Vm square by t. So sine square omega t is 1 minus, or sine square theta is 1 minus cos 2 theta divided by 2. We have used this expression already. So you have to only integrate it with 1 minus cos twice omega t divided by 2 dt. When you integrate this, you will have t, and cosine is minus sine 2 omega t divided by twice of omega. Apply the limit 0 to by 2 square by 2t. So this will be t by 2 minus 0 for the first part, minus sine omega t. It will be by cancelling out that 2 here and minus sine of 0. Because are you following this? Are you following this integration? So mathematics only. So what is cos 0? It will be equal to 1. Because no response I am getting. T by 2 minus. Now you can substitute what is equal to capital T. Capital T is 2 pi by omega. Okay. So we'll have here it is equal to cos of 2 pi minus cos 0 divided by 2 omega. So cos 0 is 1 and cos of 2 pi is also equal to 1. So that will be equal to 0. So this term will vanish from here. So what remains is we will have Vm square divided by 4. So that is our right hand side. And on the left hand side, we are having Vrms square. So we can write as Vrms is equal to Vm by 2. So for a halfway rectified voltage, we have Vrms is equal to, or V effective is equal to Vm divided by 2. Okay. So for a sinusoidal wave, Vrms is equal to Vm by root 2. For a halfway rectified voltage, Vrms is equal to Vm by 2. Okay, so you can do this exercise. I hope many of the textbooks are also containing the solutions for this. Now we'll take another function which is a square pulse. So can you find out what is the average and effective value for this? Using the same method. Okay, so do this as an exercise. So in the evening class, we will compare the results. So copy this question. I hope many of you are already saturated. So in the evening class, we'll discuss the result and see the remaining portion of this. So after this, we will be seeing what are the some of the standard signals, which is like unit step function. Then you will be seeing what is a delta Dirac function, or otherwise called as the delta function or impulse function. Then we'll see how we can represent the network in which a switch is attached, and you throw the switch at various positions. So how we can analyze such a network uh, by representing that in terms of this standard function, that is unit step function as well as the delta impulse function. Then we'll see how a capacitor charges and discharges by closely understanding what is meant by an exponential function and what is the called as time constant. Okay, so that will be the second part of this lecture. We'll see all these things in the evening. Then we'll do a lot of numerical problems, and we'll conclude this chapter today evening. And the next class we'll start with Laplace transforms. So I hope any doubts you can ask me. Otherwise, we'll see in the evening, 6 o'clock. Any doubts?
No, sir.
Okay, so meet you at 6 o'clock in the evening.
Thank you, sir.